You're welcome to Exam Scholar channel. If this is your first time of coming across this channel, kindly subscribe to this channel and click on the notification icon to get notified when I release video like this. This video is a continuation of carbon chemistry. So if you haven't watched a previous video on carbon, in which we extensively dealt with carbon as a compound and look at inorganic compounds of carbon, kindly watch it, as this video is a continuation of what we have been learning. In this video, we are going to look straight into organic chemistry. So what are we going to learn in this video as regard organic chemistry? We are going to look at organic chemistry and its application. Then we look at organic compound. Then we talked about common organic compounds and their uses. So without further ado, let's start the class. Now, what is organic chemistry? Organic chemistry is a subdiscipline within chemistry. Now, it's one branch of chemistry, one aspect of chemistry that study the structure, properties, and reaction of some compound. And what is the name of that compound? Organic compounds and their material. So the aspect of chemistry that deals with the study and the structure, the properties, and reaction of organic compounds and organic material. We call that aspect of chemistry organic chemistry. The study of the structure and the determination of their structural formula. So in organic chemistry, you are looking at organic compound, you are studying the structure, and then you want to determine their structural formula. Then you also study the properties, which include physical and chemical properties, and you evaluate the chemical reactivity to understand their behavior, so that you can use this behavior to predict this compound. Application of organic chemistry. Where can we apply the knowledge of organic chemistry? The knowledge of organic chemistry can be applied in pharmaceuticals and medicine. So there are some drugs that they are made using organic compound. So that is why organic chemistry can be applied in pharmaceutical and medicine. So we also have food and cosmetics. Organic chemistry can be applied in food and cosmetics. There are some foods that are organic. There are some drugs, some supplements of food that they are organic in nature. So we also have cosmetics. Some of the cream that we are using are body spray and the likes. Their composition are from organic material, organic compounds. So you can apply organic chemistry in making such products. Now we have petrochemicals. Now petrochemicals are chemicals that are gotten from petroleum products, from crude oil. Such chemicals can be used for making insecticide, for making nylon, all these polymers. They can be used for making grease, different chemicals. Now, knowledge of organic chemistry is also applied here in petrochemicals. Knowledge of organic chemistry is also useful in refineries as well. Now, organic chemistry can also be applied in material science and engineering. So we have some materials that they are organic in nature, e.g. we have plastic, which is a material that can be used in material science and engineering. Plastic are made from organic compound. Polymer, plastic, and the likes, they are from organic compound. Now let's now talk about organic compound. We need to understand organic compound. What is organic compound? The earlier scientists believed that they are substance that is isolated from living things as a different type of matter that cannot be synthesized artificially. So when we talk about organic compound, the earlier scientists believe that these are compounds that you can get from living things. What is living things? Plants and animals. It's a special type of compound, matters, that you cannot synthesize them or get them artificially. So which means that in the laboratory, you cannot just combine some chemicals together to get this compound. This is the belief of earlier scientists. Not until a scientist came up and then he was able to discover that, come on, we can also get organic compound from the synthesis of non-living things. That is to say, when you have some compound in your laboratory, combining them together, you can get organic compound. And what is the name of that scientist? The name of that scientist is Friedrich Wöhler, which is a German chemist. So now, he refuted this aspect of vitalism. Vitalism simply means that something that you cannot get from chemical reaction, just like human being, how we came to existence. We came to existence by vitalism, because you cannot combine compounds together to form human being. Okay, now this happened in 1828. He was able to synthesize an organic compound, which is a urea, a bodily fluid from non-living material, which means he was able to make something that looks like urine. In Yoruba language, we used to call it ito. He was able to do an experiment, perform an experiment. He was able to synthesize this in the lab using some inorganic compounds. And what did he use? He was able to use this compound, ammonium cyanate, and he heat this compound. He was able to heat this compound, and this compound decomposed to form this organic compound, which is urea, a bodily fluid. Now, he was able to refute the vitalism of organic compound. Now, we haven't defined organic compound. So, what is now organic compound? Now, to define organic compound or organic molecules simply means they are compound or molecules in which carbon is present as the principal element, bonded to hydrogen and other carbon atoms. Let me explain this. Now, in inorganic chemistry, inorganic compound, you have composition of different elements combined together chemically. And each of these elements, they dictate the behavior of that compound. Each of them, they have a say, equal rights in that compound. When it now comes to organic compound, the one that is dictating the aim of affairs of that compound, the one that is holding the compound, is carbon. So which means that carbon is now present as the principal, the major, the divining, the shape giver, the compound. So let's take for instance, when we have some compound like CO2, carbon dioxide. Now in carbon dioxide, it is not an organic compound because carbon is not spearheading the behavior of CO2. What is now organic compound? It is a compound in which carbon is dominating as the principal element that is now bonded to hydrogen and other carbon atoms. So which means that some compounds such as carbides, silicon carbides, calcium carbides, some carbonates which are calcium carbonate, CaCO3, some cyanide that is present in cassava. We have some cyanide present in cassava. Example of cyanide is sodium cyanide, graphite, carbon dioxide, carbon monoxide, some oxide of carbon. They are all classified as inorganic. They are not organic. Carbon is present here, but carbon is not the principal element. That is the difference between organic compound and inorganic compound. So any other compound that is not having carbon is inorganic compound. Some compound that are having carbon, that carbon is not dictating the behavior, that carbon is not the principal element, they are also inorganic compounds. Now, example of organic compound, we have the likes of methane, butane, our natural gas, liquefied petroleum gas, butane, propane, They are all organic compounds. Now, these are facts about organic compounds. Now, the largest database lists up to 10 million organic compounds. So we have more than 10 million organic compounds. Now, the potential of organic compound is estimated to be up to 10 raised to power 60. Wow, so large. So which means that organic compounds is more than inorganic compound. Now let's look at the reason why we have numerous organic compound. The existence of so many organic molecules is a consequence of the ability of carbon atoms to form up to 4 strong bonds to other carbon atoms, resulting in chains and rings of many different sizes, shape, and complexities. Carbon atom can form single, double, and triple covalent bond. All these things simply means the ability of carbon to catenate. This is called catenation. Due to the catenation ability of carbon, if you haven't watched the previous video on carbon and its compound, go and watch it. The ability of carbon to form multiple bonds, to form different bonds of different length, of different complexity, to form rings. This ability is what leads to numerous organic compounds. So that is why we have almost infinite organic compounds. Some common organic compounds, let's look at their uses. We have methane, CH4. Methane can be used for the production of light and energy. The lighter, your lighter, the gas inside that lighter is mainly methane. Most of them contain methane. Now, methane, production of light and energy, making methyl alcohol, also for the formation of formaldehyde and chloroform and the likes. We have some organic compound that can be used to form another organic compound. So methane is part of them. Now we have butane. In a liquid state, it is used as LPG fuel. Now the gas that used to fuel, the cooking gas, we have some that are butane and we have some that are propane. We have butane, the one that usually smell, that the smell is skunk, is butane. When you feel, you feel gas, you discover that there are some gases that they smell. The smell is very cold. The one that is light is propane, and the one that is skunk, that the smell is deep, is butane. So butane can be used as LPG fuel. Now we have ethylene. Oh yeah, come here. For ethylene, now let's go back to biology. Ethylene is plant hormone. Okay. Now ethylene is used in fruit ripening and fruit preservation.
Ethylene or ethane can also be used for making anesthesia. Let me quickly explain the meaning of anesthesia. Now, anesthesia, they are drugs or drips that is given to patients when they want to perform surgical operation on them in theater. Now, these drugs are given to reduce pain and to block some memory, to make sure that they are not conscious. Even if they are conscious, they are unaware of what is happening as the operation is going on. Another inorganic compound, this time around not organic compound, inorganic compound that can be used for making anesthesia is dinitrogen oxide, also known as laughing gas, N2O. Now, this same ethane or ethylene, when combined with oxygen, you can get a flame that is known as oxyethylene flame, which can be used for welding and coating of metals. Another organic compound is acetylene, also known as ethine. Ethine. YNE will end the name. Now look at this very well. Acetylene is different from ethylene. Is different from ethylene. Ethylene is ethene. Ethene. ENE will end the name. While acetylene is ethine. YNE will end the name. Now for acetylene, it can be used for production of light. For oxyacetylene flame, we have oxyethylene flame when you combine oxygen with ethene or ethylene, we now have oxyacetylene flame, which is oxyentine flame. When you combine oxygen with what? With ethine. So you have oxyacetylene flame. Now it can also be used for making marceline anesthesia as well, in making neoprene, artificial rubber, and in artificial ripening. Let me explain artificial ripening for you. Now, when you have banana, for some market woman that used to sell banana, they will buy banana that is unripe and they quickly want to sell it. They are now going to buy calcium carbide that we call cambad. They used to call it cambad in my local language. Calcium carbide. They will ramp it with that banana and they will pour water on it. So water will react with that carbide, calcium carbide, and acetylene gas will be produced. This acetylene gas will now ripe the fruit. Some even go as far as injecting this gas. They will inject it into the fruit. That is why we need to be careful with all these fruits that we are buying. And another use of this acetylene is welders, all these people that we call panel beaters, that they used to do the body part of vehicle. They are going to buy oxygen gas in one container. The other container, they are going to buy carbide that we call calcium carbide. It's just like a stone. They will put it inside that cylinder and they will pour water there. They will pressurize it and pour water inside it so that this gas will be produced. Now to polyethylene. We have polymer of ethylene. Now this can be used for making electrical resistance in wire. The part of wire, that insulator on wire, most of it are being made using polyethylene. Now polyethylene, also known as polyethylene, can be used for making nylon, bottles, pipe, bucket. Now they are used in the production of non-crackable bottles that cannot crack. Now you know that we have different types of plastic. We have thermosettings plastic and we have thermoplastic. Thermoplastic are type of plastic that you can reshape and remold them when you increase the temperature on them above 100 degrees Celsius. That is thermoplastic. Now polyethylene form thermoplastic, plastic that can be remolded or reshaped. That is polyethylene. Now we also have polystyrene, which can also be used for making plastic again. Polystyrene can be used to make thermoplastic as well. Now, because we have different types of plastic and plastic are being made for different purposes, you cannot compare the kind of plastic that will be made for bottles, your water bottles, and the kind of plastic that will be made for accumulator for containing acid. You know, the one that will contain acid should be strong. It should be a type of plastic that cannot be attacked by acid. So one of the plastic that is being made for plastic, we use polystyrene for it. Don't forget that this word poly is coming from polymer, when you form a giant molecules. Okay, now polystyrene is used for production of caps of bottle of acid in making the body of the accumulator cell.
Now let's now make comparison between organic compound and inorganic compound. Let's look at the properties of organic compound with respect to inorganic compound. Now, the first thing we want to talk about is bonding within the molecules. Let's observe the bonding between the molecules of organic compound and inorganic compound. For organic compound, they are covalent. All organic compounds are covalent, not electrovalent. While inorganic compound can be covalent and electrovalent. So that is why mostly are ionic, but we also have covalent inorganic compound. Let's look at the forces between the molecules, how strong they are. For organic compound, they are generally weak, and inorganic compound, they are strong. Now, which implies that due to the weak force between the molecules of organic compound can easily decompose. You can easily decompose it compared to inorganic compound, because for inorganic compound, the force between the molecules are very strong compared to organic compound. Okay, now let's look at the normal physical state. For organic compound, we have some organic compound, they are gases, they are liquid, or they solid that have low melting points. But for inorganic compound, most inorganic compound, they usually have high melting points solid. We also have inorganic compound that are gas, but the ones that are solid and liquid, they usually have high melting points compared to organic compound. Now let's look at the action when you try to burn them. Let's look at the flammability. Organic compound are highly flammable. Let's do a practical example. Your perfume can, please, when you want to dispose it, don't dispose it inside fire. Because inside your perfume, we have organic compound there. Esters. Now, when you try to dispose it inside fire, you are going to hear an explosion. The bottle will fly due to explosion because organic compound are highly flammable. Oh yeah, your gas, your cooking gas, is it not flammable? Petrol, is it not flammable? So that is why most organic compound are highly flammable. Now, for inorganic compound, they are necessarily non-flammable. It's only few of them that is flammable. Now, let's look at the solubility in water. Now, organic compound, they usually have low solubility in water compared to inorganic compound. We also have some inorganic compound they are not soluble in water. But the solubility of inorganic compound is usually high compared to organic compound. Now, we have some organic compound that they are soluble in water. The one that contains OH and COOH. They are sparingly soluble in water. Now, let's look at the conductivity of aqueous solution. Can we use organic compound from electrolyte in electrolytic cell and electrochemical cell? Let's look at it. Now, conductivity of aqueous solution. Organic compound are non-conductor. Even though we have some organic compound that can conduct some electricity a bit, that can dissociate to form hydrogen ion. The likes of carboxylic acid, they are weak acid. But most organic compounds, they are non-conductor. Inorganic, they can be used as a conductor. We still have some inorganic compound that they are non-conductor. The one that they are conductors, we have acid, base, and salt. This one that doesn't fall into acid, base, and salt, they automatically become non-conductor. But the conductivity of organic compound and inorganic compound, for conductivity, we give it to inorganic compounds.
All right, look at what we have learned so far. Now, what do we learn in this video? We're able to talk about organic chemistry, subdiscipline within chemistry that looks at the structure, the reaction, the synthesis of a compound that we know as organic compound. Now, we talked about organic compound, that their organic compound are carbon-based compound in which carbon is the predominant element. Now, we look at the properties of organic compound. We look at it that they are covalent, they usually have low melting points, they have high flammability. Then we consider some examples of organic compound and their uses. We talked about the likes of methane, LPG, butane, propane. We talked about them. Now we're able to look at the one that is used for plastic. We talked about polyethylene, polyethylene. We talked about polystyrene, the one that can be used for making plastic, and foam. Polystyrene is also used for making foam. Now we talked about catenation, the reason why we have numerous organic compounds. Now we talked about application of organic chemistry. It can be applied in material science and engineering, in food and cosmetics, in clothing as well. We have some organic compound that can be used in textiles. We have some clothes that we are wearing that they are made from organic compound. Now we talked about pharmaceuticals and medicine. Organic compound are also used in making drugs. Now, if you haven't subscribed to this channel, this is high time for you to subscribe to this channel and click on the notification icon to get notified when we release video. Have you been able to learn one or two things? Now, comment it in the comment section. Let me see what you have learned so far. And make sure you join our online community in which we give out free tutorials, live tutorials to students that wants to write exams. Now, I have a question for you. Answer this question in the comment section. Comment. Answer it in the comment section. What is the name of the organic compound that is used as organic solvent? That is the first question. The name of organic compound that is used as organic solvent. Comment it in the comment section. You can watch this video again to learn that. Now, another question is, what is the compound that is synthesized to form Urea? Answer those two questions in the comment section. Now, you can get that from the beginning of this video. So answer it and comment it in the comment section. And what were you able to learn? All right, thank you for watching this video.